A photodetector is a semiconductor device which records optical radiation and converts an optical signal at the input into an electrical signal at the output of its photodetector. A photodetector is designed for receiving remote control commands in the infrared band. The structural circuit of a photodetector includes a photodiode and an integrated chip. The latter performs the function of automatic regulation of the gain level of commands received by an infrared photodiode. The chip and the photodiode have a screen. Many structures external metal. Housings of modern products of such series as SHH and TSSOP are made of dark plastic, which is a high transparency light filter perceiving infrared radiation. In many appliance designs, a filter is installed at the front of the appliance housing or has none, as the photodiode itself has originally been produced of black plastic. Let's have a look at simple connection circuit including a photodetector, which, for example, in the future can come in handy for testing remote controls, often used to work with a variety of appliances. Let's take a common photodetector. It has 3 pins. Red positive side connected to a regulated 5 volts output and mass total. The first option is the easiest. The structure includes a photodetector, a 1 kilo-ohm resistor, an LED for indication, and a 5-volt stabilized power supply. Let's verify the correct installation. The positive side of the photodetector should be connected to the anode of the LED. Let's verify the correct installation. The positive side of the photodetector should be connected to the anode of the LED, and it is the positive output to the stabilized power supply from the photodetector output. We connect an LED's cathode through a current limiting resistor. The mass is the negative side of the stabilized power supply. In this case, the neutral cord is the output of the photodetector. Let's use a common remote control for testing. The second option, using a key bipolar transistor, includes a photodetector, one more resistor of 600 ohms, a bipolar transistor with a PN junction, an LED, and an optional additional acoustic indicator, a piezoelectric transducer. Connect the output of the photodetector through a 1 kilo-ohm resistor into the base of the transistor. In this case, a transistor collector is a negative terminal. That is, it is connected to the negative side of the stabilized power supply. The emitter is connected to the cathode of the LED by a current limiting resistor of 600 ohms. We connect the anode of the LED to the positive lead of the stabilized power supply. Next, connect the transistor collector to the negative side of the power supply. Connect the power supply. And now send a signal from the remote control to the photodetector. Next, connect an acoustic indicator, a piezoelectric transducer. the positive side of the photodetector to the positive output of the power supply, the negative side to the emitter of the transistor, and check both LED and emitter indicators together. The simplest circuit discussed above is the basic foundation for construction of circuits, for coordination of various appliances between the source of infrared signals and their receiver for further transformation and switching to the desired operating mode.